How do you develop your Golang application? You write the Go code and write Dockerfile. Maybe you are using the multi-stage Dockerfile, right? But what if I tell you that there is even a better way for deploying your Golang application to Kubernetes without using Dockerfile? Yes, you heard me right. In this video, we'll be discussing about a tool called Go, and in the end, we'll also be deploying it using BuildSafe. Yes. So let's say you are building a Golang application, and for that, there are tools. Obviously, you can use Docker files, but Go is one such CLI tool that makes it very easy, simple, and secure to build the Golang images. Now, how it does is, so it builds the Golang binary. So it uses the exec command to build the binary, and then it puts that particular binary, which is built using the Go build, on top of a small, very small base image. And earlier it was distroless. I think now it's chain guard, but still, even with the current version that I have, when you do brew install Go, it's still distroless. So I don't know why it is not chain guard yet, but you can replace it and do whatever you want to do. So it puts that on top of the base image and then makes the binary as the entry point. Also, it then pushes to the container registry using HTTP. So you actually do not need Docker daemon at any point in the complete process. So there is no Docker file required. So why Go? Like, Go is simple because you don't need to write anything. You can simply do a Go build and you can define the registry where you want to kind of, push the image. Go builds are usually fast because the Go build, because it does on your system, your development environment is there, and Go build is faster. So that is why Go build is fast, and you can actually make it even faster by setting the Go cache environment variable. So it already uses, automatically reuses the Go build cache from your system. And now, because the Go itself supports the cross compilation to other architectures, so that is why the build and push of the images supported by Go is also multi-arc. So Go can build the multi-platform. Like Go builds are multi-platform. And also it has the support to build Windows images. Yes, it has. Now coming to the security part of it, one of the most important thing that Go does is it adds SBOM information when it generates. So it generates the SBOM information and attaches that to the image that is created. SBOMs is software bills of material, which is just a metadata about the software, like which license, name of the author and stuff like that. So it generates the SBOM in SPDX format by default, and you can also disable it. Also, it lets you pass the static assets. So for example, if there are any static assets that you want to put with the Go binary, then you can use something which is called code data. So you can create the directory, set the code data path, and do all that information as well. It also has Kubernetes integration. So in your deployment, when you are creating a deployment in the Kubernetes, you can use the image as go:// prefix for the image which is there. So we can do some sort of integration. So we'll be doing an end-to-end demo, and we'll be seeing how to deploy the Golang application using HTTPS without using Dockerfile, using Go. So let's start doing that. So I have created this repository, Go to Kubernetes, and it doesn't have anything yet. So what we'll do is we'll clone this one. And now what we'll do is we'll create main.go. So I already have the main.go prepared. So it is just handling a few of the functions, /ping, add, delete names. So basically a simple text box where you can add, delete, and do the ping on the specific path. And also it will get the HTML file from the static directory. So we need to build that. It will be running on port 8080. So it will be running a simple server, HTTP server on port 8080. So this is all the handle functions which are there. So first is like for ping handler, so like if it's ping, so it will run pong. And if it's regular one, it is serve the index.html file. For the add, doing bunch of logic to add the name and append the name. And for the delete also, it is doing the appending in a different manner. And then for the handling of the names, like when it will be just names, it will be giving you the results over there. So that's pretty much it. mkdir static and vi static index.html. So this is the HTML with all the with little bit of styling which is there, and then go.mod file. So let's first run it. Go run main.go and starting the server, localhost 8080, and you can see Sayam Pathak, add, demo, and we can delete. So all the functions which are there, which are working, and even ping should return in Pong. That's what was there. all the function calls were being handled. So this is a very simple Golang application. But now we want to actually deploy it and we want to make everyone to be able to access this application. How to do that? How to do that using Kubernetes, and how to build this particular thing? Like, what do I do next after writing my logic? So the main idea for this particular thing is not understand, like, if you're not able to understand what is there in the code, it's completely fine, because that's not what we are trying to learn over here. What we are trying to learn over here is, what do I do after that? What do I do after I have written the main logic? So now you just need to do brew install co, or you can do it via the go install as well. So brew install co, once you have co, what you can do is, we need to define the co Docker repo. So that's the environment variable that I was telling about. So if you specify, you can specify anything, like Docker is the default one, but I want to use ttl.sh because it's anonymous and I do not have to provide any other information, any other auth information. So co Docker repo ttl.sh/kubesimplify/go co build, and it will start building. Since I've already built, so it will be very fast. And you can see the base image is the chain guard image, which is being taken from here. Earlier, it was the distress image. Like, I'm pretty sure, because when I did just a few examples back, it was the distress image that was taken over here. This is the image, and you can also see it has published the SBOM information as well. So it has the SBOM information going within the image. And now what we are going to do is, I already have a Kubernetes cluster created on AKS, Azure Kubernetes, but the tool that I have used is Ksctl. So Ksctl is a CLI tool that was built by Kubesimplify team, mainly Dipankar, and he has been single-handedly driving it most of the times. It's a very simple CLI tool to kind of create clusters in different cloud environments, and that's what we have created in AKS. So you can do Ksctl get clusters, and you can see there is a demo cluster that I have created on Azure. And if I need to switch to that cluster, so it's basically Ksctl switch --region --name and --provider Azure. And then it says that this is what you need to set. So I set it, Ksctl get nodes. So I have the cluster up and running over here. One more step before we start installing stuff onto the Kubernetes cluster is publishing the image that we just built. So it is just publishing that particular image to ttl.sh so that we can pull it later on. Now we have Ksctl get nodes. We have the bare bones Kubernetes cluster with us, and we'll just keep this image, and we'll just verify with Docker run as well on -p80808080. And yes, it's run. So we are okay with this. The first thing that we are going to do is install the Ingress controller. So it's simple, Ksctl apply Ingress Nginx controller. It's installing that. The next step is installing Cert-Manager, because we want to deploy this particular Golang applications onto a domain and then make sure it is HTTPS TLS. And for that, we definitely need Cert-Manager. Now let's create a deployment. So vi deploy.yaml. So it's a simple deployment of Golang server with 2 replicas, labels, and the container port 8080. The main thing that we have to specify over here is the image. So let's go back, and we'll be giving this particular image that we just Docker run with. And save. And Ksctl apply -f deploy. The deployment is created. Ksctl get pods, and we can see both the pods are up and running. The next step is to create the service. So vi svc.yaml. So simple service, which is labels with label this, and which is selecting the app go server, which we defined in the deployment. This is the node port type. We can create the cluster IP as well. So that should not be a problem, because we'll be creating Ingress. Ksctl apply -f svc. Ksctl get svc, and our service is created. The next step is to actually create an Ingress. So what we are going to do is have ingress.yaml. So API version, networking, K8s, IOV1, Ingress, and we say Cert-Manager issuer. This is something we have to create, which is cluster issuer with the name of let's encrypt prod. And then Ingress class is Nginx. It is deprecated now, this particular thing. In the roles, we define host as, let's say, because we are doing everything from scratch. So what we'll do is we will give it as golang.kubesimplify.com. And here also we'll give golang.kubesimplify.com. And the secret name that we have to use is demo, which we'll define in the certificate part. In this particular thing, basically what we are trying to say is if you hit golang.kubesimplify.com, it should come like, obviously it's configured to our Ingress controller IP. And whenever this comes as this host, it should be hitting the Ingress controller, and the controller should look, okay, if this is the host that it is coming with, it has to go to a service which we just created on port 80, and that port 80 is internally internally doing the container port 8080 of the pods that we are running. And for the TLS as well, since we want to do HTTPS, so we have to define the TLS section as well within this particular YAML file. Now, before applying this, what we need to do is we need to get Ksctl get svc-a, and we need to get the load balancer IP of Nginx Ingress, which is 51.8.24382. Now, what I'm going to do is we'll go to Squarespace account with kubesimplify.com domain, and I will be adding a new A record in the DNS. So add a record, which is Golang, and type is A record, and the IP address is the IP address that we just defined. So Golang, this is added. So now if I try to hit golang.kubesimplify.com, it is properly routing and giving us 404 not found. Now what we'll do is we'll be creating the Ingress, and the next step would be to create the cluster issuer, the Cert-Manager resources, in which two are critical, which is the cluster issuer and the certificate. So let's do that. vi cert.yaml. So first is the cluster issuer. The name is let's encrypt prod, which we used actually in the Ingress as well. And you can see we also have the Ingress class as Nginx, and then we move to the certificate. The secret name is demo, the same secret that we defined in Ingress. And the issuer reference is above one, let's encrypt prod. And here we'll just say Golang and DNS name as well. So let's apply that. So we have Ksctl get certificate, and hopefully in some time we should have the certificate as true, and we can see the certificate has become true. Now if we go back and we hit golang.kubesimplify.com, and you can see it is secure. The connection is secure. It is HTTPS traffic which is coming over here, and our application is deployed in production, and you can see it which is running. And this is on an Azure Kubernetes cluster, Azure cluster AKS, which was created using Ksctl. So all in all, we have simplified the process. So Ksctl to create the cluster, Go to build the application, which is fast, secure, and then deploy it using Cert-Manager, Nginx Ingress controller onto a Kubernetes cluster. So the overall flow that is there is the application. So it's a Go application. We build, you can build using Docker, but we have not done that. We have done first Go. And next, obviously, the next step is what we'll be doing using BuildSafe, OCI registry, and you can push to Docker or GHCR, which is GitHub Container Registry, or the ttl.sh, that is anonymous one, good for demo purposes, and then the Kubernetes cluster deployment. Now, the next step that we are going to do is deploy it using BuildSafe. So I have a video where I've already explained what BuildSafe is. It's also a CLI tool which uses Nix under the hood to build your applications securely. So you can actually package your application with 0 CVEs and make sure it is very secure. Since it is using the chain guard as the base image, so it should not have any vulnerabilities, but we can still test it using grype. So grype and the image name. So you can see no vulnerabilities found. But this is in the case that they just switched to the chain guard images. Chain guard images are cool, and I also have a video on that. I will put the link on chain guard images as well. So before this, it was using the distillers image. Distillers images are really, really good. But the core used this particular distillers image, which is GCR distillers base image. And even this particular image has some of the vulnerabilities in that, which I last checked. Yes. And you can see it has 15 vulnerabilities. So if you do brew install Go, then this is the image that is being used. If you install it via the Go library, then it will be using the chain guard image. But as per the documentation, with the newer releases of brew as well, it should be using the chain guard images. And you can also update. But the next tool that I'm going to explain is the BuildSafe tool. So which uses Nix under the hood. So let's see again. What we are trying to do is we are trying to build a particular application without Dockerfile. So Go is absolutely the best, the beast which is out there. But we'll also try BuildSafe. BuildSafe is a very fancy tool. It also does the supply chain security, right? Uses Nix under the hood, which is even better and gives you more control on what you want to select as the base image. So actually, it is much more than that. So you can have a complete control over how you want to build the application and ship it as the base image that you can use in your Docker files and whatever, wherever you want to use it. So let's do a BSF init. So it has created a few files, bsf.htcl file. The main file that we have to edit is bsf.htcl because we want to do the export. So by default, it generates this. But if you want to install or export it as an OCI artifact, then you have to add another block, which is OCI. So in here, we have given OCI dev name cmd env var exposed. If you want to learn more about BuildSafe and BSF.htcl, all the other files and components and what it does feature wise, then there are two separate videos that I'll put in the link. Put the link in the description and you can watch that. So this is there. Now what we'll do is we'll do BSF build. So BSF build. So the build is completed and you can see the results are there in the bin binary file would have been created in the BSF results directory, and that's the Go server example binary that has been created. So, and if you see the bsf.htcl file, you'll be able to see that this is the binary that we want to execute on port 80 for the particular OCI artifact that we want to create. So the next step is the BSF OCI dev, the block name that we defined, platform, Linux, MD, and load Docker. So you can see the image is loaded to the Docker daemon. We can do a Docker push. And now inside our deployment file, what we can do is we can change this image to the new one that we have built using BuildSafe. Ksctl apply -f deploy. It's configured. It's container creating. And we can see it running. And if we go back to our example, we should be able to see that things are running again. So everything is running as expected. So what we have done is we have created a Golang application, built it using Go and BuildSafe, deployed it onto a Kubernetes cluster, AKS, using a deployment service, Ingress, cluster issuer, and certificate. One last thing would be to just check once for the grype image, because this particular image also do not have any vulnerabilities. And even if you want to add this, it will not have any vulnerabilities. That's the beauty of BuildSafe, that you can select the packages and make sure that you are getting the right packages for your development environment, which are present over here, or the runtime environment. And you can specifically choose a particular version which is CVE free using the PSF search. You can search the packages. You can watch that in my other video. So yes, Go is cool, and I would definitely recommend using Go for building the Go languages. Let me know in the comment section what you are using for building the Go applications that you are using. So what you're using, let me know in the comments, but I definitely think Go is the better choice. And now BuildSafe is definitely the better choice. So make sure to check out BuildSafe. Now BuildSafe will very soon be having a very good UX to even create the base zero CVE base images very easily. So stay tuned and get involved as soon as you can. And that's it for this particular video. And if you like the video, enjoy it, please share it with your friends, because now you have learned how to deploy a Golang application onto a Kubernetes cluster with HTTPS. And all the files and everything will be there on the Git repository that I will again link in the description of the video. Thank you so much for watching, and see you in the next one.